Welcome guys to this video on the quotient rule. Okay, so in the previous video we had a look at what's going to happen if we try and derive the product of two functions. Okay, in this video here we're going to have a look and try and see what would happen if we try and derive where we've got two functions being divided. Okay, so this here is going to be having a look at something called the quotient rule. And the word quotient derives from when you divide two different numbers, the answer is actually properly known as the quotient. So that's that tie into the idea of division. Okay, so we're having a look at this kind of situation. We've got a function being divided by another function. So an example of that might be this one here, where we've got x squared plus 6x minus 3, say, over 2x minus 1. So this is our function x here, and this is our function g. Okay, so how do we divide that? Well, as you might appreciate, this is going to be quite difficult to do anything with in terms of trying to write it in a simpler form. Okay, and so really an algebraic type of simplification is not really an option here. Okay, so this quotient rule will be quite useful in this kind of situation. Right, so how do we go about trying to derive? Well, we're starting with this function here. So from first principles, our derivative would be sorry, I just got distracted there. Okay, so our derivative would be where we've got fx plus h minus, divided by gx plus h, and we're subtracting from that our original function all over h, and of course I should have put in front of that our limit. Now back in the previous video, the one on the product rule, we saw that this here and this one here can be replaced with an equivalent expression. So I'm simply going to use that result. I'm not going to try and prove it again. If you aren't too sure about what I'm going to write next here, okay, well, what you need to do then is to look back at that previous video. Okay, so this fx plus h can be replaced with this equivalent expression. And gx plus h can be replaced with this equivalent one for that we get once again from the same kind of working. So it's g dash x plus gx, and we're subtracting this still, and all of that over h. Now I'm just going to go over to this side here, and we may have to work sideways because I'm sort of running out of room vertically a little bit. Okay, so what I'm going to do now is we're going to put this over a common denominator, this part here. So our common denominator would be simply this times this. So bracket, and then now that would mean that if that's the new common denominator, I need to multiply this fraction by gx. Bracket there, and this fx would need to get multiplied by all of this, so minus fx times all of this. Okay, so just double checking there, that looks right, and remember we've got all of this still over h, and we've got our limit as h tends to 0 in front. Okay, so let's tidy this up. Well, for a start, let's try and get rid of the one fraction being divided by something else. So let's just go over here for a moment. What I've essentially got is a fraction being divided by something. Well, that's equivalent to that fraction, and this division can be thought of as multiplying by the reciprocal of the bottom. So we end up actually simplifying this to a over bc. So if I use that, okay, then what would I have here? Well, I'd have all of this top part times 1 over h. And I'm also at the same time going to expand out these two things here just to save a bit of time. So we're going to have, let's expand out this, we're going to have h gx f dash x plus fx times gx minus h fx times g dash x minus fx times gx, now all over that bottom line times 1 over h, so we end up with h and then that bottom line, so gx, and yep, I think we might expand this into here now. So remember this was a g dash here, so that's going to be h gx. Okay, in fact, no, let's just put down what we had before. I was trying to do too many steps at once. Okay, so next step, we do have a little bit of simplification we can do. Notice that we've got that and that cancelling. And if you look at the remaining terms on top, we actually have a common factor of h here and here. So let's take that out. So h bracket. So I'm going to put f dash x times gx. It's the same thing, but just swapping the order of those two terms being multiplied, minus g dash x times fx, and if we take, okay, this multiply this out, we're going to have h squared here. Yeah, so the bottom line, let's actually just leave that bottom line just unexpanded just for now, because we're going to be cancelling that h in a moment. Okay, so cancelling once again what we can, which is this h here. And I'd like to still keep it on one page here if I can. So limit h tends to 0. Okay, that top line there, that hasn't changed. All over. Okay, now let's expand this out now. We're going to have gx times h g dash x, so let's write that as h gx x times g dash x, and I've got gx times itself, so that'll be gx all squared. Okay, so if I now substitute the 0 in here, well, yes, part of this bottom line would become 0, but not the whole thing, so it's not undefined. So this here will now equal that top line over, and this part becomes 0, but this remains. Okay, and that there is basically what's called the quotient rule. Okay, so let's write that summary on another page here. Okay, so we started off with, let me just get that back, this situation here, and we ended up with this formula for the derived function. F dash times g minus g dash times f all over function g all squared. Okay, now we can sort of write that in a easier form to remember without all the x's, as long as we remember that f and g here refer to functions. Okay, so one example of how this can be used. Let's go back to that question we had on the first page a moment ago. Okay, so function f would equal the x squared plus 6x minus 3, and so its derivative would be 2x plus 6 using that shorthand rule. Function g is equal to 2x plus 1, so g dash would equal just 2. So working out our derivative, f dash times g would be 2x plus 6 times function g minus g dash, which is 2, times function f all over function g squared. Okay, so this can be simplified further, and I think we should do that here. So this is going to be 4x squared plus 2x plus 12x plus 6 minus 2x squared minus 12x plus 6 all over that bottom line squared, which I'm going to leave in that squared form. Okay, simplifying the top line, we get a 2x squared, that minus that, that's 14x, take away 12x, so it'll be 2x, and 6 plus 6 is going to be 12, all over 2x plus 1 squared. Now, one thing we should perhaps do is to see if this could be factorized to have a factor of 2x plus 1, and you can check that for yourself, but it actually doesn't. So this is actually our final answer here. Okay, so that's the quotient rule. Might be worthwhile going over that working back on the previous page again, just to see where this is coming from. But that's it, and we'll follow this up the next period. Okay, catch you guys.